These are the basic tools required to carry out the principal tasks related to servicing refrigeration and air conditioning equipment. Specifically, they are the following: vacuum gauge, high and low pressure manifold gauge, hoses, safety glasses and safety gloves, vacuum pump, scale, recovery unit, refrigeration ratchet, toolkit for press fittings, tube cutter, deburring tool, oil can, vernier caliper, flaring tool 1, flaring tool 2, ruler, pipe bender, engineer's square, torque wrench, pipe calibration tools, igniter, electronic leakage detector and calibrating leak. To roll off the copper tube, separate a coil of copper tube from the bundle. Choose a straight line on the floor to unroll it against. Align the copper tube along the straight line by gently stepping on the end of the tube and rolling it off along the straight line. Mark the required length. Using a tube cutter, carefully cut off the tube. Be aware that too much pressure could damage the tube. Straighten the cut section of the tube by rolling it on a flat and clean surface. Deburr the tube with a deburring tool and make sure no debris gets in the tube. Check both the inside and outside diameter. If necessary, calibrate it using the pipe calibration tools. It's important to note the difference between soft annealed and hard copper. Seal the remaining copper tube to prevent moisture and dirt from getting into the tube. For joining the pipe, flaring may be required. These are the two main different flaring tools. Oiling is a very important first step. Then we move to the actual flaring process. Insert the clamping jaws with the required diameter into the rotating flaring tool. Next, clamp the tube into the device. Press in the pin and start the flaring process by gently turning the wing screw. Unplug the pin and spin the windscrew several times. Press in the pin again and turn the wing screw back. You can unclamp the tube. Now check the required diameter and the flared tube end. Finally, clean any oil from the tube. The first step is to measure and mark the copper tube. Clamp the bending former into the vise. Then insert the copper tube into the bending former and secure it with the lever segment. Align with an engineer's square. You can use duct tape to prevent permanent marks on the sliding block. Move the lever to bend the tube to the required angle. Finally, remove the tube, check and correct if required. For press fit connections, you will need copper tube, connectors, stabilization inserts, lock rings, sealant, and a non-metallic abrasive mat. And the hand assembly tool and assembly jaws. First, attach the required jaws into the tool. Clean the tube with the abrasive mat. Then apply the sealant approximately 5 mm from the tube rim. Insert the stabilization insert into the tube and slide the connector over the tube rim while turning the sleeve. Then clean off the excess sealant. slide over the lock ring with the beveled side pointing forward. Clamp the prepared connection into the assembly tool and press until you feel resistance. Clean off the sealant and the joint is complete. Clean both the copper tube and brass fitting with a non-metallic abrasive mat. Apply the flux approximately 5 mm from the tube rim. Insert the tube into the brass fitting and turn both simultaneously. Clean off the excess flux. Then you need to estimate the amount of brazing alloy that will be required. It's approximately 3 times the outside diameter. Turn on the tank and allow nitrogen to flow through the tube. Start and adjust the torch. Direct the flame only onto the tube until the working temperature has been reached. Then you can apply the brazing alloy. Make sure to allow the tube to cool before removing the burnt flux. Be aware that if brazing is carried out without a nitrogen flow, cinder will accumulate inside the tube. Take the prepared copper-copper connection and allow nitrogen to flow through the tube. Estimate the appropriate length of phosphorus brazing alloy. It's about 3 times the outside diameter. The moving flame indicates the flow of nitrogen. Start and adjust the torch. Direct the flame onto the connection until it glows dark red. Then, apply the brazing alloy evenly around the joint. Again, be aware that if brazing is carried out without a nitrogen flow, cinder will accumulate in the tube. It's important to first carry out a pressure strength test and a pressure resistance test using nitrogen. The maximum test pressure is determined by the part of the unit with the lowest pressure tolerance. Ensure that the pressure is the same throughout the system. Check each joint and connection for bubbling by applying the spray. Bubbling indicates a leakage. Turn on the electronic leakage detector and calibrate. Slowly move the detector several times over a calibrated leak device. Check each of the joints and connections with the electronic leak detector for any leakages. The required tools are a vacuum gauge, high pressure and low pressure manifold gauges, and a vacuum pump. Make sure that the unit is not pressurized, that is, it's under ambient pressure. Connect the hoses to the unit and pump. Open all the shut-off valves. And start the pumping process. The evacuation process is complete when a vacuum of approximately 1 millibar has been reached. Before refrigerant charging and before the unit is set up, ensure the pressure strength, pressure resistance and bubbling tests have been carried out and the evacuation has been completed. Close all the manifold gauge valves. Turn off the vacuum pump and disconnect it from the system. place the refrigerant cylinder on the scale. Set the scale to 0. It's important to put on safety equipment, to cover any bare skin, and to wear safety gloves. Connect the cylinder to the unit. Evacuate the charging hose and the manifold. Open the liquid valve on the cylinder and charge the refrigerant through the high-pressure side on the manifold. Always keep an eye on the scale. And beware of overcharging. Place the recycling cylinder on the scale. Then connect the cylinder to the recovery unit and connect the recovery unit to the system. Open the liquid valve on the recycling cylinder. Open the manifold gauge and the hoses on the high pressure side towards the recovery unit. Start the recovery unit. Only now can you open the inlet valve of the recovery unit. Keep an eye on the inlet pressure. It's important that you continue recovery until the system is empty. Close all the hoses and valves in reverse order. It's important to wear refrigerant-resistant safety gloves. Using a Schrader quick connector, screw the coupler onto the service port of the outdoor air conditioning unit. Attach the quick connector to the hose. Snap the quick connector into place. The pressure can now be tested and the unit can be charged. Remove the hose by unlocking the locking lever. Cut the insulation material to the required length. Cut the material lengthwise. Make sure not to cut into the inside of the material. Use glue only in a well-ventilated room or outdoors. Be sure to wear disposable gloves and apply glue to the cut surface. Allow the glue to dry for a short time and check the surface for stringing. Then, insert the tube into the pipe insulation and press the cut surfaces together, starting at the lower edge of the surface. Be careful, as too much pressure could damage the insulation material. Strip the required length of insulation from the cable. Be careful not to damage the individual wires. Strip the insulation from the individual wires using a wire stripper. Do not twist the wire strands. Apply the wire end ferrules and crimp with the end sleeve crimping pliers. Repeat the procedure for the other wires.